Hey guys, it's Dr. Wolf explaining Chapter 8. Just a warning that it's been a while since I've made instructional videos, so please bear with the speed and the pacing and my ums every now and then. So Chapter 8 is hypothesis testing with two samples, and one of the big ideas in stats is that we often want to compare two things. For example, we might make a claim at St. Andrew's School that the average SAT scores of girls is greater than the average SAT score of boys. Or we might make a claim that the proportion of seniors who are happy with the distance learning is less than the proportion of juniors that are happy with distance learning. So in other words, we're interested in comparing two samples. So in this chapter, we'll see hypothesis testing with claims about two population parameters, and we'll also see confidence intervals to estimate the difference in the sizes of two population parameters. So you'll be using your hypothesis testing skills from Chapter 7 and your confidence interval skills from Chapter 6. So in Section 8.1, we'll be skipping it. Again, the reasoning is we're skipping the z-inference procedures for means because it's not very reasonable that those population standard deviations are known. So moving into Section 8.2, we'll be testing the difference between means, and we've got a couple of conditions here that the samples are going to be independent, the population standard deviations are unknown, and we'll also be assuming that those population standard deviations are unequal. You'll see that there are 5 separate objectives, and as we work through those, I'll be posting a separate video for each one. I mentioned there's one assignment for the section, and that's got a due date of next Wednesday. And when you look at the problems in the book, please ignore the instructions and carry out either a hypothesis test or a confidence interval as shown in the methods in our notes. Okay, so moving from page 1 to page 2. Page 2, we've got formulas in the chapter. You'll notice that they look quite bit more complicated perhaps than formulas that were in other chapters. If I break this down for you, up here in the top left, we're going to give you some equations that are going to work for the inference procedures that are starting out in section 8.2. 8.2, we'll be using this equation for our t-test statistic. We'll be ignoring the equal population variance scenario and only working here in 8.2 when the population variances are unequal. The chunk of equations that are over here on the top right, we'll be working with these equations in section 8.3, and we'll be working with these equations over here in section 8.4. Okay, a little intimidating always to look at them in the beginning, but as the chapter progresses, we'll get more comfortable with using them. Also, we're going to do quite a few calculator commands in the chapter. The calculations in the chapter are maybe a bit more difficult to work out and do by hand, so you will be happy to see that there are some shortcuts we can work with. The first two are going to be for section 8.2. The second two, some shortcuts for 8.3, and then some shortcuts for 8.4. Okay. Moving on to page 3. We've got the Z table, because when we do a confidence interval for comparing two proportions, we will need Z critical values. And we've got a T table here for you, because when we do interval estimates for two population means, we'll be needing a T critical value. Okay, and finally here on page 5, we're going to get into the first section of the chapter that we're covering, which again is section 8.2. First objective, determining whether two samples are independent or dependent. So in a two-sample hypothesis test, Remember, as I mentioned, that we're interested in comparing two parameters from two populations. As this chapter progresses, we'll be doing claims that ask us to compare two means or claims that ask us to compare two proportions. Now, when we compare two means, we are going to have to decide if the samples in the situation being described are independent or dependent. Samples are independent if the sample selected from one population is not related to the sample selected from the other population. And then dependent for the situation where we have pairing or matching going on. So each member of one sample corresponds to a member of the other sample. A little graphic right here to show you this concept is if I have two independent samples, perhaps I have, like I mentioned, maybe girls who have taken the SAT versus boys who have taken the SAT. So I have a sample 1 with girls in it, I have a sample 2 with boys in it. Those would be two independent samples. I could make that a dependent sample situation if I'm doing the following. Let's suppose I took a group of seniors who had taken the SAT. I wrote down their scores, and then I had those seniors take a test prep class. Then take the SAT again, and now I'll have another set of scores. So if the same seniors were measured here as well as here, there is now a pairing going on, so that I've had a before a test prep class score and an after score. So when the same individual is measured twice, we tend to have a situation where we have dependent samples. Right here. Typically each person measured twice. Okay, so for you to try that, example 1, if we look at sample being the weights of 65 college students before their freshman year begins, and then the same 65 college students after their freshman year, clearly I would have the dependent sample situation because those same 65 freshmen are measured twice and there's a pairing involved. If I look at the example where sample 1 is the scores of 38 adult males on a psychological screening test for ADD, while sample 2 is 50 adult females on a screening test for ADD, then clearly I've got these independent samples where it's not possible to form a pairing. Another clue here is that you'll notice that the sample sizes are different. So in that case, that's just a clue that we've got samples that couldn't possibly be paired. So they are independent samples in that situation. Okay, so the example on the bottom of the page where you get a chance to try this out. You're being asked to classify two samples as independent or dependent with explain your reasoning. Okay, so example 5. Sample 1 is the maximum bench press weights for 53 football players, and sample 2 is the maximum bench press weights for the same 53 football players after completing a weightlifting program. So in those few seconds it took me to read that, hopefully you've been able to think that those would be dependent samples. And the reasoning would be that the same 53 players are measured twice, so they are paired samples. Okay, example 6. Sample 1 is the IQ scores of 60 females, while sample 2 is the IQ score of 60 males. Okay, and in this case, I would clearly think that a sample of females and a sample of males are independent samples in this situation. Okay, so maybe the males and females are not paired. Okay, so that first objective was ultimately just deciding in a situation where we wish to have an inference about two samples, whether they're, whether they are independent or dependent. Okay, I'm not going to delete my video just for that one sneeze, so there ends video number 1.